Welcome back, 7th graders. This week, we are going to learn about roots. Our objectives are to find the positive and negative root of a number, also to determine that there is no rational number square root of negative numbers, and to find the cube root of a positive and a negative number. Our I can statement is I can use square and cube roots to solve equations involving perfect squares and roots. The vocabulary words that we are going to use along this lesson are inverse operations. These are pairs of operations that, as you know, undo each other. So far, we have worked with addition, which is any term by itself with a positive in front. And we know that addition undoes subtraction, which is any term with a minus sign in front. We also learned how multiplication undoes division. Multiplication is any term that's separated by a raised dot, parentheses, or a variable and a number sitting next to each other. While division are terms that are separated by the division symbol, a slash, or set up as a fraction. So what's new is here a square, which we are familiar with, a term raised to a power. In this case, we have x raised to the squared or to the second power. And to undo this exponential form, we are going to use the square root, which is a term under a root symbol, which can also be called radical sign. So a square root is the number that we need to multiply by itself to get the original number. For example, the square root here is, we're looking for the square root of 25. As you can see, this 25 is placed underneath the radical symbol. And then because 5 times 5 equals 25, then we know that the square root of 25 is 5. A perfect square is a number that can be expressed as the product of an integer by itself or raised to the second power. So all of these numbers down here are square roots, okay? They are basically the answer or what is produced after finding the square root of another number. So the perfect square would be the product of multiplying these two factors by themselves. So 1 times 1 is 1, therefore this 1 is a square root. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and we continue going. See, we could continue. 6 times 6, 36, 7 times 7, 49, 8 times 8, 64, 9 times 9, 81, and we can continue infinitely. A perfect square root is the positive square root. So every positive number has two square roots, a positive 1 and a negative 1. So the principal square root is the positive 1. A cube root, the cube root is one of 3 equal factors of a number. When we talk about cube, we know that this is what it means. A raised to the third power equals b. So a cubed equals b. We have it here. The cube root of 64 equals 4 because the number 4 is used as a factor 3 times, and as a result, we get 64. A perfect cube is the result of multiplying the same integer 3 times. So just like before, we can see here 1 cube is basically multiplying or using 1 as a factor 3 times and obtaining 1 as a result. We have 2 cube, which is using 2 as a factor 3 times, and the result would be 8. So this number 8 is a perfect cube. We repeat that for 3 cubed, 4 cubed, 5 cubed, and we can continue going. Now down here, we find cube roots and we find perfect cubes. So the result of multiplying these integers or these cube roots 3 times is it's a perfect cube. So if we multiply 1 3 times, we obtain 1 as a result. If we multiply -1 3 times, our answer will be -1. If we multiply 2 3 times, 2 times 2 is 4, and 4 times 2 is 8. We can repeat that for -2. -2 times -2 is +4, and then +4 times -2 is -8. And we could continue going along this chart infinitely once again. And finally, we have a radical sign. The radical symbol is used to denote roots. Its parts are, well, this here is our radical symbol, and it has a radicand, which is the number underneath the radical sign, and it has an index, which tells us the root of the expression.